Here we go. Finally got my audio running. And here we are again. We're in week 2. We're on assignment 4, and I'm just continuing the graph and adding complexity because no study is really, truly that simple. And I'm going to go back to that table and hopefully share the right window with you this time. There you go. We looked at the examples of chi-square and t-test and ANOVA last time. And the difference between an ANOVA and an ANCOVA is the letter C. Well, it's true. It's just added a C in there. And that C is for control. You'll notice at the top of this table, there's a control variables. And up till now, we haven't had any control variables that we were looking at. But when we get to we do have a control variable. We can have one or more. So there's no limit to how many control variables we could include in an ANCOVA. Why would you want to control for something? Well, let's go back to my, let's see, let's go to my other window because I made a list. I will stop sharing that, and now I will start sharing. Actually, let's just share desktop. That'd be the easiest thing. Hopefully. And then I can flip over to where I'm writing up the current version of discussion post or assignment 4. And I gave an example where I said, well, you know, if you're studying teacher retention, the dependent variable is categorical, it's stay or go, but what can affect teacher retention? Well, you know, a lot of things. And on the list I've posted here, there's family issues, there's death, there's birth, there's health issues, there's the level of collegiality in the school. Is it a Shark Tank or does it feel like a team effort? What about the level of collegiality in the grade? If the school feels great, but none of your 3rd grade teachers want to work with you to help you do a better job in 3rd grade, that's gonna possibly affect whether you want to stay there or not. Okay, administrative support is always a factor when teachers decide to stay or leave. Student violence. Hey, if you're in an inner city and it doesn't even feel safe to be there, that's definitely a compounding variable. It's not something that we can control, but we can control for it. That is, we can statistically take statistics from different schools where there may be nothing happening or rarely anything happening at one school, and there may be 100 incidents at another school, and maybe we don't want that to affect how we analyze things. Maybe we want to take that piece out of the puzzle. We use that as a control. So there's a million things that we could list, and I have you brainstorm for the first part in assignment 4. But here we go to back to my chart, and I took the same basic questions as the ANOVA. If I did this part, that's an ANOVA. Because it says, do differences exist between teachers at different SES levels? That's one categorical independent variable. In terms of teacher longevity, that's one continuous dependent variable, the number of years of teaching. So that would fit the ANOVA model up here, but I added this piece right after what I've highlighted. Okay, now I'll highlight the part that would not be an ANOVA. ANOVA would not have a controlling variable. If I want to look at SES as my main thing, then I better control for other things like administrative support and school tone, which we know from the literature, from your lit review, you're going to know what other things contribute to longevity, and you got to do something to take those out, or else you won't know how much of an effect the SES could have played. So that's what controlling is about. It's about taking those pieces out statistically so that we can see how much our chosen independent variable really does affect things. So it's basically an ANOVA with a controlling variable. In this case, I use two controlling variables and I called them CVs. All right, that's an ANCOVA. We already did, we've got a MANOVA. What's in a MANOVA? MANOVA has one or more categorical variables and two or more dependent variables. So my example, do differences in SES, that's one categorical variable. Do differences exist in terms of teacher longevity, number of years at school, that's one dependent variable, and the number of years at the same school, which is a different dependent variable. Number of years of teaching means you can hop to school, but we're adding up, and the dependent variable there is all of your years of teaching, whereas dependent variable 2 is years at that particular school. And so we can look at the SES and see whether it has a significant difference, makes a significant difference on years of teaching overall or years of teaching at just the same school. That's a MANOVA. See? The difference is there's more than one dependent variable. And then, of course, to add one more level of complexity to that, there's a MANCOVA. We started with an ANOVA. We added a C for ANCOVA, which was taking a control variable out. Then we added M to ANOVA, where there were multiple dependent variables. That's what the M is for. And now we're looking at a MANCOVA, where you have at least one independent variable, at least two dependent variables, and at least one control. So this is going to be a really complex question, and here is my example. Do differences exist? See, I keep going with the parallel language here. Between two or more groups, okay, for me that was between teachers at different SES levels. And you know, is there a difference in terms of teacher longevity? That's one dependent variable. At years of teaching, 2 is years of teaching at the same school, just like the last question. So this is the same as the last question, except for this last part, where I added controlling variables, where we consider these numbers, these, the scores for administrative support, the scores for school tone, and then we statistically remove the effects of those and take a deeper look at this. And since longevity, staying, teacher retention, and how long do they stay is a really complex question. It makes sense that we would look at it in multiple ways and control for variables that we know have an effect, but it's not what we're testing. Whew. Okay, so it's really, I haven't seen one of those yet. In one of our dissertations, it is a worthy project. Multiple regression. How much variance is accounted for by this long list of independent variables? In this case, we're looking at the variance in longevity, number of years. In this case, I've limited to one school. I just picked one continuous variable because that's what you have to do for a multiple regression. There's only one dependent variable, and it's got to be continuous. So number of years of that in school counts for that. But multiple regression means there's going to be multiple independent variables, and here it's not the other things were does it make a significant difference? Does it make a difference? Does it make a difference? The word difference is not in this basic question up here. Okay, this one says how much of a difference? How much does it account for? If we take into consider these independent variables, how much of the longevity is actually accounted for when we look at school tone, district support, salary, the socioeconomic level of the students, how much is accounted for? Is it, a 40, 20, 10, 10 split? And there's going to be correlations, and there's going to be an equation, and there's going to be coefficients. And each coefficient will tell us just how strong school tone is compared to district support. That's the follow-up question, because when you look at the equation that you get out, you'll know about what percent can be accounted for if these are the variables that are put in to see how much of a difference they make. You can compare those coefficients and say, well, salary is making twice as much of a difference as school tone is, or vice versa, by comparing those coefficients. So that gives you really interesting data. Here again, there's probably more variables in the whole equation than you can factor in. And every time you recognize that and you don't control for it, and even when you control for some variables, you don't control for everything. So listen carefully. I'm about to tell you how to wave the magic wand and account for those other variables. You say, one of the limitations of my study is that I did not account for these other variables that may affect it, but it was not a focus of this study. We've got to be able to say what our limitations are, and we'll talk more about limitations, but that's one of the things that we do when I make a list of 20 variables that could change the dependent variable outcome. I can't put them all into my things. I can do multiple t-tests and try as many as possible, but you're going to get worn out. And you can't control for every variable, so you have to recognize and show the reader that you know there are other things and that it's a limitation of the study that you did not account for them. So we do as much complexity as we can because real life is really complex. It's not a simple matter of whether we implemented this curriculum or not. It's also a matter of what time of school year it was, whether state tests had been done already or not, because you know kids kind of slacked after that, and so do teachers. Christmas break was in the middle of your intervention. What's that gonna do? That's gonna mess up your data. That's something you maybe didn't have control over, or you should have control for it. But there's another way that we can control for variables that's not in this design. It's in the way you set things up. If you don't want to worry about, if you're studying an experimental Spanish teaching technique in 2 classes, and in 2 classes you're trying the traditional way, you want to make sure those 2 classes have about the same achievement level up to this point. When you do that, you're controlling for it by establishing that they're matched sets of kids. And that changes what t-test that you can use, for instance. And when you use a matching t-test, the odds that you get the result you want are actually higher, but that's because they're respecting the fact that you made sure that the groups were equivalent in other ways, that they're matched as much as possible. So design matters, the question matters. What you want to know shouldn't be determined by I'm scared of an ANCOVA. It should be determined by what you want to know. Write out all the things. That's why we're playing all of these different scenarios out. All of these questions by the end of the week are going to be written out by you with your variables and your questions that you have in your context that are meaningful to you. And you're going to look at lots of confounding variables. You're going to list them at the beginning of this assignment. Then you're going to go through and fill in the more complex tests with some of that in mind. And pretty soon we'll write up a general plan for what a study could look like if you did a quantitative study, but that's not this week. This is enough for this week. This is a lot to digest, and you really do need to read everyone else's questions that they post and the comments that others make. And when I see an error, I will go in and correct it periodically. I'm not going to come on everybody's if we're on the right track. I'm going to let you guys run with it, but if I see that it needs to be tweaked, I will let you know. And so keep coming back, read the post of others, make comments, and keep checking to see if anything's updated, because this is where you sort out whether one of these is really what you want to know. And if it is, then that may be the path that you go for your dissertation. Now, you won't make a final decision. You'll pick from among these temporarily, but we're going to go through all the qualitative, or many of the qualitative choices, and then you'll decide between the two of the best that you like from each quantitative and qualitative. All right. Well, I think I've done enough damage here. I will post this, and I'll post the video, and I will see you all online. soon as I end the meeting.